Okay, so okay, so is it expected from y equals squared when I graph it on Desmond? Go if I go up 1. A new equation. Please. Because that's why. Can you compare y equals to x? Wider, so is the blue one wider than the red one, or is the blue one narrower than the red one?
For sure. Thank you.
Because you're putting 2 and not x.
x. So you see how here? How do you delete? Okay. I'm just going to delete this. You put x squared. Okay. All right. Now, eyes on me, please. Eyes on the board. Okay. So you tell me that the blue one is vertex. What's your now let's grab x squared. Compare the green one to the red one for me. Is the green one narrower than the red one, or is it wider than the red one? It's wider. Okay, so what is the 2 and the 0.5 doing to your graph? They're making it either wider or they're making it narrower. Okay? All right, let's look at this and see why this is happening. So I'm going to give you an example here, if I can find an elastic band. Does anyone have an elastic band? Does anyone have an elastic band, guys? No? I can't find one either. Actually, there is one. Yeah, found one. Okay, so here's your original y equals x squared graph. Okay, eyes on me, please. Eyes on me. This is y equals x squared. Okay? If you want to make this narrower, what do you do with it? Stretch it. Which way? Up and down, right? What do we call this? If it's up and down, it's vertical, right? So in order for me to make this narrower, I'm going to have to do a vertical stretch. Okay? If I want to make this wider, what do I do? Can I pull on it down? Right? If I pull down on it, look what happens to the so it's a vertical compression, we call it. Okay? So if I'm going to make it wider, I have to compress it. So press on it vertically. Okay? You're right. You can stretch it horizontally, but we don't do that here. Okay? What we do is we either vertically stretch to make it narrower, or we vertically compress to make it wider. Okay? So if I'm looking at this, remember this is my original parent function, the red one. To make it narrower, I had to put a 2 here. Okay? So that 2 makes your graph vertically stretched. And that 0.5 makes your graph vertically compressed. Okay? Do you think if I have y equals 3x squared, so if I put here y equals 3x squared, what do you expect to happen to the graph? Do you expect it to be narrower or wider? Narrower? Okay, so let's try that. So 3x squared. Look, it's even narrower than the y equals 2x squared. Okay? What if I have y equals 7x squared? Right? Even narrower. So, if your a value is greater than 1, it's going to cause your graph to vertically stretch. Okay? Causing it to be narrower. Now, what causes it to be wider? So this is wider here, right? Can you describe the a value for me? It's less than 1. Okay? So it's between 0 and 1. okay, to be specific. So give me a value of A other than 0.5 that's between 0 and 1. 0.7. So I'm going to just delete these. Let me back here. I'm going to include the 0.5. Okay. Then I'm going to go to y equals 0.7 x squared. Okay. We have too many colors now, blue and red. Can I pick the color here? Here, this is what I'm going to do. Y equals 0.5 x squared. Y equals 0.7 x squared. So you notice that the 0.5 x squared and the 0.7 x squared, they're both wider than the original one. Okay? How about if y equals 0.2 x squared? That's also wider, right? So what makes your graph wider is if you have an A value that's between 0 and 1. Okay? Do you guys notice that your vertex still at 0, 0 did not change? Yes? Okay. All right. So let me go back here. And let's write a few things here. So, did the direction of opening change? So it's still up for both of them, right? Did your vertex change? So it's still 0, 0 for both of them. Did your axis of symmetry change? It's still x equals 0. What changed is this one was narrower. And we call that vertical stretch. And this one was wider, and we call that a vertical compression. Okay? Now let's see what happens to the graph if I have a negative A value. So I'm going to go back here. I'm going to delete these. And let's look if I have y equals negative 2x squared. I have to give it to you later. So, what do you see here? What happened to your graph? It flipped. And it's narrower. Okay? If I have y equals negative 3x squared or negative 5x squared or whatever you want, it's going to flip and it's going to be narrower. Okay? So what causes it to be flipped, to be opening down? The negative. And the 2 or the 5 causes it to vertically stretch. What happens if I have y equal negative 0.5 x squared? It flipped again, right? And it's wider. Okay? So, let me go back here. Did the vertex change? I'm going to go back here. Did your vertex change? No. Did your axis of symmetry change? No. The only thing that changes is the direction of opening. Now it's opening downward. the vertex did not change, so it's still at 0, 0. The axis of symmetry did not change. Okay? This one is wider. Sorry, this one is narrower, I mean. So I'm going to call it vertical stretch because that's what we know now. So this is going to be VS, vertical stretch. And it's going to be, we call that reflected. Reflected means flipped. Okay? So opening down, reflected. Okay? And then for this one, we have a vertical compression, so it's called VC. And we also have a reflection. Okay? So here's what we learned. When I have an A value, the sign of the A indicates the direction of opening, yes? When A is positive, the parabola opens up. And since it opens up, it has a minimum or a max. So if it opens up, it has a min or a max? Min. And then when A is negative, the parabola opens down and has a max. This is known as a reflection. Okay? So here's how you're going to remember this. Negative A value. So, negative. What does the word N, what does the word N? What does the word negative start with? And which way does N open? Right? So if A is negative, which way does it open? Yeah. And then the letter N opens down. Okay? And if A is positive, that means you're happy, positive, and you're smiling, and you're opening upward. Okay? Now, the value of A describes the shape of the parabola. So we said that when A is between 0 and 1, the parabola is narrower or wider if it's between 0 and 1. It was wider, right? So because it was like this, right? And then it was wider with between 0 and 1. So it's wider than y equals x squared. And we know we call this vertical compression. Okay? Or in other words, you see me writing it as VC. And then when A is greater than 1, so 2, 3, 5, negative 5, whatever, the parabola is skinnier or narrower, whatever you want to write. It's the same thing. Then y equals x squared. And we call that vertical stretch. And I will be writing it as VS. Okay? So if I give you something, if I give you, let's say, y equals negative 4x squared, you're going to tell me that the parabola has a reflection, right? Because of that negative. And then you're going to tell me that it has a vertical stretch because it's 4 and 4 is greater than 1. Does that make sense to you? Okay. Let me just stop here for a second.